Hello everyone, this is Varun Sai Krishna from Bennett University. I would like to take this time to present my topic TOC. Why do we study TOC? This is a foundational question. At the end of this topic or this TOC, we will understand a mathematical model. The most important aspect of this TOC is to provide mathematical model of the computer of various different tasks. So TOC provides the mathematical models of a computer. So it will be more easier for scientists to know the mathematical models, and he can easily find out what computers can do and what computers cannot do. And we can also find how efficiently the computer can solve the problems. And the most important model of the TOC is Turing machine. And this was invented by the Alan Turing and named his machine as his name after his death, called Turing machine. This is the most important model in the mathematical models of a computer that we are going to know in this topic TOC. This Turing machine is same as the computer, and what the problems you can solve in the computer can be solved in the Turing machine also. And this machine was invented during World War II. During World War II, Germans were attacking the England, so the messages or the codes were passed through radios or through air transportation or air media. So the commander for German was Hitler. So Hitler would pass to the soldiers to attack which country or which city, or when to attack, or when to go for a war. So what the England people and mathematicians had done is that to encode the code sent by the Hitler, and that was encrypted. So to decode the encrypted message, they want to build a machine, or they want to see all the messages sent by the Hitler. So what they have done is, previously when Alan Turing was not there, so they wanted to do it on paper, like they just want, and that machine Enigma was a machine which encodes the code sent by the Hitler, and this Enigma machine consists 159 million settings per 1 day. So after 1 day, all these settings will get loose. So what they have done is, before the Turing machine invented this, Alan Turing invented this Turing machine, they just converted they just tried each and every setting, and each people tried each and every setting, and they just converted. So it takes many years, it will take many years them to decode the message, so when they want to attack their city. So what they have done, what Alan Turing was done, like, so the messages were coming from the Enigma, so we have to create the machine which decodes the messages sent from the Enigma. So that is all the thing. But Alan Turing was also a mathematician, so he just wanted to build a Turing machine that is a mathematical model. First he was a mathematician, then he was done code breaker and everything, and now he is the he is a more fundamental of foundation of computer science. So now see, actually these mathematical models are used in compiler designs, or we have, and this TOC is not only the bulk theory, these are also used in the real-time advantages. So TOC are, there are many real-time applications are there in present life. So the compiler design was also made by the models are in the CD. See, suppose we have written a C program and we need to compile it. So we use the compiler like Turbo C plus or anything, and this gives the executable file. So how is this converted to this? So here the compiler plays a major role. So the compiler checks the syntax of C, and if there are no any errors, and the high level language is converted into mission level language. So how all these are done? These all are done by using the models. They are directly used in the compiler, are the mathematical models that we are going to learn from this course called Theory of Computation. So now see, now let's take another example also. See, suppose you are filling a form in Google, and we need to enter the email ID of yours. So how will you enter? So we have a certain pattern, like the first name consists of capital A to Z or capital A to Z or 0 to 9, or we can have dot or underscore, and then we need ampersand and some set of string on and dot and some set of string. So if we enter in the correct way, it gives the email ID is valid. So if we do not follow this pattern, or if we do not write any of these, if we use any of the other characters, it gives the invalid. So how does the system knows the email ID that we have entered is invalid? See, as we have learned in the last semester OS, we have in the OS we have Linux or Unix. We have a command called grep. Grep is a command used to pattern matching system. So whatever mail we have entered, if it is valid, and it gives the correct. So all this is done by using the command called grep. Grep is also available in Python or Java and everything. So this is the simplest model. So this model is called finite automata or finite automata machine. So here we follow the matching system. Here we follow the matching system called pattern matching system. So this is the finest and smallest model that we will learn in TOC. This will be very helpful. Next, see, now how does our system know that this is the exact pattern? How will it learn from it? So we have to learn our system that this has to be the exact pattern. So how will our system learn? So by using we'll pass to our system called grammar. So this grammar is taken from linguists. Linguists are study of languages or computer languages. So we have taken grammar from this, and we will pass this grammar to our model to learn. It will learn from this, and whatever we have entered, if it is valid, it shows valid. If it is not valid, it will not show as valid. This is the finest model and simplest model called finite automata, one of the mathematical model. Now let's see another mathematical model called PDA. PDA. PDA is the complex model, because see, now if we write any program in C or C++, if we pass to our compiler, and if the syntax is correct, then only it compiles the program, otherwise it doesn't compile the program. So how does our compiler compiles that, whether it how does it check the syntax is correct or wrong? Because we will write in many ways, the program can be written in many ways. So this compiler should allow that whatever the program we have written, if it is syntactically correct, it can execute the program, or it can create an executable file. So how is this syntax working? This is also one of the model that is the best model in mathematical models of TOC. So PDA is also useful, and the third most important model is Turing machine. Turing machine is the most important model that we can learn in our course Theory of Computations, because Turing machine is a model, like if we have taken our now modern computers. So what our modern computers can do, this model also can do. If we have taken our modern languages, C, Python, Java, what these languages can program, this Turing machine also program. So one model can do everything what we have now. So see how important, how finest is this model is. Now this Turing machine gives us whether what can computer do and what cannot computer do. So computer can do things, and computer cannot do also things. So, and it also gives how efficiently the computer solves the program. See, if you have seen the movie called the Imitation of Image, there Alan Turing was not able to decode the codes sent by the Enigma machine. So what he has done is that was an infinite problem. That was an infinite thing. So if he has passed the infinite thing to his machine, he couldn't predict the output, or he couldn't terminate it. So what he has done is he has sent an executable code called Hail Hitler, so that every code that was sent by the Hitler got encoded and it got decoded also. And here also the best example is halting problem. Halting problem was, see, if there is a program called P and we are passing a program called Q. So if this program is passed to the program P, whether it has to be terminated or halted, or it has to be not terminated or not halted. So this we have designed a program P that accepts any program and it can be halted or not halted. So what the thing is, if it gets terminated or halted, it would be easy. But if it doesn't terminate or doesn't halt it, so it goes on infinite thing. So it goes for the infinite loop. So the thing is that if it goes the infinite loop, we cannot predict the output. So that was the thing. Alan Turing has proved that halting problem cannot be solved through Turing machine. So this is a still mystery that no machine can, or no model can solve this halting problem. So Turing machine, this is the Turing machine is called. He also proved that halting problem cannot be solved through Turing machine. So like this we will learn some of the problems from simplest to complex, finite automata and PDA, and then we'll come to the Turing machine. And now also so that is the reason Alan Turing was called as a father of modern computing and father of artificial intelligence also, because during the World War or before the World War, the first person who has published a novel called Can Machines Think? Can Machines Think? He was the first guy who published the novel that Can Machines Think? That's the reason he was called as the father of modern computing and father of artificial intelligence also. So these are the things that Turing machine and all these things will do. I hope like this is the overview of TOC, and I hope you have gained some overview of TOC and some knowledge to learn this. Thank you all.